Hi, I'm Eleanor McLaughlin,
And I'm Jessica Sankis.
and we're doing the sport of track and field sprinters.
So what we'll be going over today are what are the most important aspects of the sport, how do runners properly execute the proper patterns, what is the anatomy that is utilized when sprinting, how does the body allow us to perform this maximal effort movement, and what is the importance of testing.
Track and field sprinting is a popular sport featuring races from 60 meters to 400 meters requiring speed, power, and adherence to lane, start, and finish rules.
Acceleration allows the athlete's ability to rapidly speed up from a low static position during different periods of the race. This will add emphasis on the hip flexors, hamstrings, glutes, trunk muscles, and gastrocnemius or the calf muscle. Maximal velocity speed is the upright sprinting phase characterized by high stride frequency, proper mechanics, and force application. The muscles involved in this action include the entirety of the lower body and upper body muscles to aid in stabilization. And reaction and control are two things that often counteract each other. Sprinters must have the ability to maintain a neutral spine, core stability, and trunk flexion that assists their movement in their proper manner.
The joints include the quadriceps, which are used during the extension during the push-off, using the rectus femoris and vastus muscles along with the knee joint for stabilization. The hamstrings allows for proper extension of the hip and bending of the knee while participating in normal gait patterns. The gluteus maximus is used for the powerful hip extension during the push-off and for acceleration. The gastrocnemius is used for ankle plantar flexion from the ankle to provide force during the push-off phase of sprinting. The abdominals and obliques are used to stabilize the torso and allows athletes to brace throughout the movement. And the latissimus dorsi aids in stabilizing the torso while creating force to continue to push forward.
Some lower body joints involved include the hip, which is crucial for hip flexion and driving that knee up, and extension, which is pushing off. The knee plays a major role in flexion during the recovery phase and extension during propulsion. The ankle facilitates plantar flexion to push off the ground and dorsiflexion, which is preparing for the next step. And the subtalar joint controls foot pronation and supination for stability and force transmission.
The upper body joints involved in sprinting include the shoulder, which enables arm drive, enhances stride efficiency and balance, the elbow, which assists in rapid arm flexion and extension, contributing to sprinting rhythm, and the wrist, which maintains hand position and supports relaxed but dynamic arm movement.
The energy systems involved in sprinting include the ATP-PC or the phosphagen system, which provides the body with an immediate surge of energy that presents explosive efforts that last up to 10 to 15 seconds, making it the main energy source in shorter sprints. Another energy system includes the anaerobic glycolysis system, which becomes more important as the duration becomes longer than what the phosphagen system is capable of. This system is also capable of providing rapid, fast energy during short intensity bouts.
That analysis highlights the importance of explosive power, neuromuscular coordination, and injury prevention for track sprinters. Based on the physiological and movement demands, the training program should prioritize dynamic stretching and mobility work, sprint-specific drills, explosive activation and movements, lower body strength and power, core stability work, and upper body strength. The training plan should align with the biomechanics of sprinting, emphasizing injury prevention, power, and speed.
So some exercises that we would include are leg swings to enhance hip range of the motion. This could be a part of the dynamic stretching and mobility work. AB skips, which is a sprint-specific drill that to activate the sprinting mechanics. Bulgarian split squats, which are part of the lower body strength and power, improves unilateral leg strength and stability. And the Pallof press, which strengthens the core stability to reduce energy leaks.
Death jumps are part of the explosive activation to engage those fast twitch fibers. Romanian deadlifts are a part of the lower body strength and power, strengthening hamstrings, essentially reducing injury risk. Power cleans are a part of the explosive movements and build triple extension power for sprint starts. Hip thrust strengthens the glutes for powerful hip extension, essential for sprint acceleration and top speed. And metabolic slams are a part of upper body strength and develops rotational power and torso stability.
So some tests that we would also do include anthropometrics, for example, bod pod, height, weight, vertical jump. This provides data regarding potential health risks and can be used for future use for measuring progress. Max power, for example, vertical jump, broad jump, power clean, or anything regarding the 1 rep max. Sprinting relies on lower body power, especially in the start and acceleration phases. This measures explosive force production and total body power, or muscular endurance, for example, plank hold, push up, or curl up. Sprinters need endurance and postural muscles and lower body muscles to maintain under fatigue.
Um, Agility test assesses an athlete's ability to decelerate and recelerate, which is essential in drive phase transitions. For example, the 5-10-5 shuttle and the T-test. The sprint test helps determine whether an athlete needs more work on explosive starts or top end speed. For example, the 10-meter, 30-meter, and 60-meter sprints, and fatiguing anaerobic capacity evaluates lactate tolerance and ability to sustain high intensity output. For example, the 300-meter sprint test.
So the testing order that we chose would be agility, which requires quick neuromuscular response, max power, which needs maximal explosiveness, sprint must be fresh for peak speed, muscular endurance, which has less impact on earlier tests, or fatiguing anaerobic capacity, which is the most exhausting test.
For the agility test, which the purpose is it involves agility, which should remain short, around 20 seconds, to target the right energy system. If tests are done longer, this will trigger the use of other energy systems. This is most ideal for sprinters as it involves change in direction while the torso leans in different directions. To perform it, an athlete starts at cone A, sprints to cone in the middle, cone B, shuffles 5 yards to the left, cone C, shuffles all the way to the right, cone D, shuffle back to cone B in the middle, backpedal back to cone A.
For max power, we chose the 1 rep max back squat. And the purpose of this is during the sprinting pattern, maximum power is used to continue to keep the athlete in motion at top speed throughout the duration of the race. There is a direct link to force and velocity where the capacity will vary from athlete to athlete, but the integral of these two relationships explains the ability of maximizing power to enhance performance. And how to perform this is to load the bar with the proper weight according to RM, which varies from athlete to athlete, unrack and step back into squat form, and descend and explode upwards to complete a full rep.
We chose the 3-minute sprint test. The purpose evaluates acceleration, maximal velocity, and sprinting mechanics. You warm up with dynamic drills. The athlete starts in a sprint-ready stance behind the start line. On command, the athlete sprints maximally for 30 seconds. Time is recorded. Best of 2 or 3 trials is recorded with 2 to 3 minutes of rest between attempts. The goal, faster times indicate superior acceleration and power output. Both sprinters aim for a very quick time.
And muscular endurance, we chose the wall sit test. The purpose is to assess the endurance of quadriceps, vital for sprint acceleration and stability. Specifically, benefits sprinters quadricep endurance for powerful strides. And how to perform this is to lean against a wall with knees at 90 degrees, hold position for as long as possible, and record the time until failure.
The fatiguing anaerobic endurance, we chose the 300-yard shuttle test. Purpose measures the anaerobic endurance, speed endurance, and recovery capacity, all crucial for sprint athletes who need to sustain high intensity efforts and quickly recover quickly between sprints. To set it up, set up 2 cones 25 yards apart. Athlete sprints down and back 6 times, covering 300 yards. Times reported from start to finish. The average of both tries is reported. Faster times indicate superior anaerobic endurance and recovery capacity. And these are our references. Thank you.
Thank you.